Being at CppCon has been amazing because you can directly speak with the experts. I've had conversations with Bjorn Strusepp, with Sean Parent, and they're all very friendly and accessible and willing to give their opinions or advice on C++.
Hi again. So yesterday I told you a funny story completely unrelated to C++. Today I have two horror stories, which, as all good horror stories go, they must be, of course, related to C++ from my recent work history. And the common ground between them is that in both cases we did what is apparently the right thing to do, probably indeed is. So I really like making things const when possible, especially member data. I've read blogs about this being problematic sometimes because you can't move objects which have const members. But I wasn't too worried about that because what's the worst that can happen? Worst case, it will be ill-formed, it won't compile, you'll drop the const and move over with your life. So we can see here an example of a class which we have a move-only struct into which we are embedding a non-const member, and we move the outer class. It moves together with it the inner member. We can see the move constructor being invoked, no problem. Now let's make this the member const. As I said, what's the worst that can happen? Oi. Did you see what just changed there? Okay, so if you look closely at the output, we have the copy constructor now being invoked. And this code is perfectly well formed. So it turns out when you move a class which contains a const member, the synthesized move constructor or assignment, whatever, is going to add the ampersand. So in this case, it will happily create a constar value. And of course, the constar value will not bind to any move constructor of C. It will copy C, even though the outer class, the struct, is being moved. Big issue, this C could have been some huge vector, and this would not be what we were expecting to get. So from here, the takeaway that we've reached from now at work is that const data members in general are not allowed unless the outer class is, as I call it, non-transferable, both non-copyable and non-movable. I'm relaxing this rule in cases where it's mainly primitive types, which I don't really care if they are copied or moved. Second story, again, everything being done just right. We had a function, of course this is greatly simplified, a function which is looking for some string inside Windows data structures, and it's supposed to return the value of the string if it finds it. If it doesn't find it, it returns a null PTR, a perfectly legitimate return, returning by char pointer. This of course works, there's absolutely no issue here, we did the right thing. And now we get to this. We needed to put it in a ternary if together with another function that returns a std string. And all of a sudden we are in deep trouble because in a ternary if, the return type is the common type of the two types in the combined condition. And now if we are calling the first function, returns a null PTR. That null PTR will be used to construct a std string, which is always a great guarantee of a fun day when you try to construct a std string from a null PTR. So here the takeaway, unless someone comes up with a better idea, is to not return the const char pointer if it may return legitimately a null PTR. Otherwise, things like this might just happen. Thank you.